So in this video, I'm going to manually code up an AI SOC Analyst. That is some agentic cybersecurity AI that does threat hunting. Rather, I already coded it. I'm just going to show you the code and then give you a live demo in an actual production SOC environment with nearly 1,000 users and like millions of organic logs. So before we get into the demo, I just need to explain the environment a bit, otherwise it won't make sense, so just bear with me. This is the environment we use. It's a live production SOC environment, has like hundreds of users using it at any given time. Even now as I'm recording this, it has a lot of resources, maybe 300 or so virtual machines, and it's not cheap to run. It's an actual like full-on like production environment, and I'm not the only person running it. I have like a back-end engineer and like a support engineer and like a few other people, so it's not just me. But I'm the one who architected and engineered this, and there's like just a bunch of people using it. So basically how it works is there's a lot of resources in here, like virtual machines and servers and firewalls and some other stuff. And whenever someone does anything in this environment, they log into a virtual machine, they create a file, they like browse the internet, like install an application. All of those stuff produces logs, and all of those logs will be forwarded to a central repository called a log analytics workspace. And then that central repository is what our AI SOC analysts / our cybersecurity agentic AI thing that we made. It's going to query the log analytics workspace and then do some like cognitive threat hunt and then see what it can see, and it will report back to us. So just an FYI. And I need to show you one last thing before we actually get into the AI code and stuff. This is like the log analytics interface, and I just want to manually query some of the logs just to kind of show you what it looks like so you can get like a better idea, right? So there's a lot of what are called tables, and it's just basically a place where the logs get stored, and there's different tables depending on the different log types. So for our demo, we're going to be looking at device process events and then device logon events. And device process events just basically means whenever a process is spun up or like opened or started on a virtual machine or something like this, it will literally like just create a log for it, and it will get put in log analytics workspace. So basically I'm just looking at all the processes for this particular computer just for the demo, and then looking at these fields, which are the different properties for the process, and we're ordering them by the time in which they were created. So you can just kind of see like all this stuff got opened on that virtual machine at some point, and then it just gets logged, right? So like updater.exe, like PowerShell.exe, and you can kind of, the idea is in a traditional SOC, you would look through these logs, and then you would look specifically if somebody like opened it specifically like PowerShell.exe and they did like a specific command or something, then you would like create an alert based on that. It's just like some hard structured logic. But with the agentic AI / like cognitive threat hunt, it can basically look at all of the logs, or at least a big chunk of them, and it will look through and then correlate them, and then see if it finds anything suspicious based off of like the file name or like whatever. We don't have to tell it specifically like if PowerShell runs with like a execution policy bypass and like download. We don't have to like say all of that. We just give it the logs, and because like it's an LLM and it's like smart enough because it's been trained for pattern matching, it can just look at them all together and then just decide if something is malicious or not. And then again, this device logon events table, whenever somebody attempts to log into a virtual machine or server, the result basically gets logged in here along with a bunch of data. So this means like somebody tried to log into this virtual machine with the name admin, the login failed, and this is their remote IP address. And you can see a ton of people trying to log into this virtual machine with like a bunch of random usernames from like all over the world. And this is intended, right? Because it's a cyber range. We're generating like a lot of organic logs that we can use to practice threat hunting and stuff. And it just so happens to be like really convenient that we had this already when AI started like getting really crazy. And again, we're only going to use these two tables for the demo today. When we actually start getting into the agentic cybersecurity AI like SOC analyst, but there's a bunch of other tables in here. So if you just like click on this, you can see the other table. Oh, by the way, like if you want to have like access to the cyber range, like you want to practice like threat hunting, security operations, and vulnerability management, and I'm definitely going to create a course on this like immediately. Like when I'm done recording this, I'm going to start creating the course because it's like really crazy. I'll put like a link in the description. It's just the cyber range, but there's a lot of other tables is what I was going to say. So for like if somebody changes the registry or like deletes a file, there's like device file events as well. And there's a whole bunch of, like a ton of logs, right? But we're only going to use like 2 tables because I just wanted to like make this as soon as possible. But yeah, let's get into the actual code and then actual demo of the threat hunt agent. So we're finally getting into the actual hunt. I'm just going to run this code and kind of explain everything that's happening. I'm just going to run it through once, and then the subsequent times when we run it, I'll kind of stop it and really explain things as they're happening. So I'll just start this. So, and then you can see at the bottom, AI SOC Analyst at your service. What are your concerns? And then this is where you'll tell it like what you want to hunt, right? So I'm just going to put like something in like really kind of cringe English that's like really ambiguous, right? To give it instructions, just to kind of show the, I guess, the cognitive part of it. So my prompt, I'm going to tell it like, gee whiz, I'm a bit worried about if there's any sussy processes running on Windows Target 1. Can you please take a gander and see if anything looks suspicious for the last 12 hours? And you'll notice I put like 12 in letters with some cringe emojis. Papa Bear's getting fussy wussy with like a bear and some honey, you know, just to show it, right? And I'll do a lot of examples of these, right? So I'll run this, and then it's deciding the log search parameters, and it should search this from the text we put here. And then it's querying KQL, so it's looking in the in our log analytics workspace for the logs. It executed the query and then returned 378 records that is related to our request. So now it's initiating the cognitive threat hunt against the logs. So it got the records, and then AI is like looking at them. Specifically, the OpenAI's GPT 4.1 is analyzing them. The threat hunt took 34 seconds and found 5 potential threats. Press enter or return to see the results. So if we press enter, kind of look at this, it will dump everything to the screen. And I'll just kind of show the results. I'm not going to like explain them in too much depth. You can pause the screen and like look at them. And then if you want to ask questions in the comments, I will respond to everyone's comments that they ask. So if you want to like ask about these specific threats, but for each threat it found, it has like a title. So like this is, remember, these are like actual logs on like the actual cyber range, right? The environment. So the title, port scanning activity detected, PowerShell script execution, and then it talks about the time that that thing happened, what happened, and like the indicators of compromise. Confidence level, like how much of a false positive, or how can I say, it's how confident it is that this is a true positive. It dumps the MITRE attack framework, like the tactics, techniques, and procedures, and then the specific line logs, or the specific logs that show the indicators of compromise. And then these 2 particular indicators of compromise, and then it has tags, and then recommendations, and then some more notes. And I'll show the rest of these. I'm not gonna like explain them in depth like I did with this one, but basically it's really trivial for me to add on to the script. Rather, I will add on to it, like in the cyber range, I'll have an ongoing development of this AI agent, and with like coursework on stuff on how to do it. But it would be really trivial to be like, to have the next logic be like loop through all of the findings and be like, if confidence level is high and recommendation is create incident, then we can do something like create an actual incident in our SIM in Sentinel that someone can manually work through. Or we could also like automatically like isolate the virtual machine or the computer, or turn it off. All those things are like super trivial to do. And yeah, I could talk about this a lot, but I'll continue looking at these logs. I'll just like let you look at them, and you can pause it if you want. So download an execution of potentially malicious malware script, PwnCrypt 1, confidence high. ICAR file, confidence medium. High volume of some executable happening that looks suspicious, confidence medium. A use of PowerShell for registry and shellbag analysis. I don't know what this is, confidence medium. And that's all. And I do want to say really quick before we move on to the next hunt example, that thing that just happened, the analysis and cognitive threat hunt of those logs that took 47 seconds or whatever, that'll take like a normal human several hours to do, to find the indicators of compromise and the potential threats, and then to create all those reports with the MITRE attack frameworks and like everything in there. It wasn't like a full blown like report, but that'll take someone several hours to do. That was like at least like 300 to 400x speed of what like an L1 SOC analyst will do. So if you're wondering like why people are worried that their job is going to get taken by AI, it's because it literally is, at least that level of job anyway. But the good news is like we have like a lot of resources, and we can go out and study and then learn how to leverage AI and then become better, and then we can basically just do more. So I don't think that there will be like a reduction in the workforce. There will be like a reduction, but there'll be an addition as well. But a lot of positions leveraging AI, as you can clearly see, that's like what's happening, right? Okay, so the next hunt demo, we're going to do it with the device logon events. So we're gonna suspect somebody logged into one of our virtual machines. So instead of using Windows Target 1, I'm going to figure out which virtual machines in the last like 48 hours or so had the most logon activity. And that's just what this query is. These are just random cyber range members virtual machines. And this query just says, show me the computer with the most logon events in the last 2 hours. And it just happens to be this person here. So I'm going to do a query against their virtual machine. And by the way, we can build this so it can query like all virtual machines, but I'm just doing a demo for this. I'm just doing a demo. So back to our tool, I'm just gonna run it without debugging. I'll debug it later so we can like really like see what's happening. And then again, AI SOC Analyst at your service, what are your concerns? And then this time I'm gonna paste, I'm gonna issue the command in Japanese. なんかラフィウェンのパソコンをめっちゃ変な感じる。多分誰かハッカーとかは勝手にログインしましたよ。怖いよ。調べてくれ。多分今週だよ。早くしろよ。It just means like, I think somebody might have logged into this computer sometime this week, maybe a hack or something. The computer's acting weird. Please hurry up and like do the threat hunt for me. So I'm just showing you, the power of this. So I'm running it again. And you'll notice that it decided to look in the device logon events table for this name for the last 168 hours because I said probably this week here. And then it's looking in these fields. And then it queried log analytics. It made this KQL query. It returned 2,600 records. It's performing the cognitive hunt now. So this will probably take some time, but no doubt it's going to come up with a lot of stuff. So it took 28 seconds, found 4 potential threats, press enter to see results. And this is probably going to be a mixed bag because this computer is like exposed to the internet and it's just like getting attacked nonstop. So let's just like look. Again, I'm not going to like explain these in too much depth. I'll let you like pause it and then ask whatever questions you want in the comments. So threat number 1, remote brute force attempts via RDP. And it's talking about who did it. Confidence level high, because clearly that's happening. It shows some of the log lines here. Specific lines that it pulled from Log Analytics Workspace. Indicators of compromise. This would be more like a, what is it called? Like malicious entities, other than indicators of compromise. But I just built this thing in like 8 hours or something. So forgive me. And tags, and then recommendations, create incident, pivot it. By the way, all the stuff that you're looking at here, this report, this is like a fixed format. This can be like literally anything. I just like made it in a day. So, don't even like trip or worry. Threat number 2, suspicious RDP logins with valid credentials from external IP. So it looks like somebody, I think valid credentials mean the actual username is correct, but I think they got the password wrong. I'm not going to read all of this, but you can like pause it and read it if you want. The third one, possible lateral movement via RDP. Okay. Description, I won't read this. I'll just like let you read it, because if I start reading it, it's going to get really long. So lateral movement means like either it looks like somebody from like a different part of the network internal to the cyber range probably like was able to log into it or try to, or yeah, that's probably what's saying what happened. I'm not going to read this, by the way. Title: high frequency logins using this account from LAN host. I know what this is. We have like in the cyber range, we have a vulnerability management platform. We use Tenable, and it looks like this cyber range member, this user, is like doing a vulnerability scan against their own computer. You can see the computer that's trying to get in. It's called local scan engine, which is why it got flagged as a medium. Because it's probably that guy's account that probably succeeded. But I know this is a scan engine, so this is like actually like a false positive, I guess. But it somehow like knew it was, right. At least it gave it a medium confidence level, which is like really crazy and mind blowing. And again, like it's a bit more obvious, for the SOC analyst to see a brute force is happening. Like it's 10,000 login failure or whatever, 2,600 login failures. But still, it like built a report, and it found some other like nuanced stuff as well. Like 30 seconds. This will be at least like a couple hours for like a SOC analyst to like prepare this with like their human hands and stuff. It's really crazy. And don't forget the fact that we like issued this command in like cringe Japanese, and it was able to derive like the proper table and like everything. Oh my god, this is like, it's really crazy. I feel like mind blown by this. But yeah, I'm gonna do some more examples, and then we're going to like pause it, and I'm going to kind of explain things like as they're going. Cool. Okay, so I'm going to do one more hunt. This time I'm going to hunt in the device processes event table again, but I'm going to just find another random cyber range user to look at their processes. I have no idea like what's going on their computer. So I'll just look in Log Analytics. I'll just pick the computer that has the most process activity in like the last 2 days. And looks like Rafi Win is, but I don't want to get his, so I'll get like this person, Sergeant Crypto. Is just I don't know who that is. It's just like a random, I don't want to say random, but it's a person in the cyber range, right? So I will just, this time I'm going to debug the code, so it means I'm going to like pause it so I can have time to like explain exactly like what's happening. I'll try to be fast, but yeah. Okay, so I'll run this, I'll debug this. And then SOC Analyst, what are your concerns? I'm going to use like a plain English this time. I'll be like, an actual SOC Analyst. I'm worried that there might have been something going on with a malicious process or something. I misspelled process, but that's okay. On virtual machine. Please check it out. I think it happened in the last 3 days or so. Actually, I'll say 4. Misspelled. 4 days or so. Help. So when you run it, so I ran the code and I broke it here. It says deciding the log search parameters based on the user's request. So basically, I'll explain like what happens here. We say something to the AI agent, like, right, there may be a weird process on this computer. It needs to know like where to search, right? And the way that we like help it to know where to search, there's this object called tools where you can kind of define what your environment looks like. So this is going to be really complicated, by the way. This is why I'm like hesitant to do this on YouTube, because it will like get too long, but I'll do my best. But I'm going to do like a whole like course from the ground up explaining everything, so it makes sense. I'm just going to explain this like really succinctly, but this is basically like how we describe to the model like what our environment looks like. So it knows like which table to look in, right? So because I said that there's like a weird process and I spelled everything wrong, it's just a really like bad like prompt on my part, but it still can figure it out. So basically you can build this like object that describes your environment. So for example, these are the tables that exist in our environment. So device process events, this is where process creation and command line info resides. So basically the model will like look through this and be like, oh, okay, like which one of these tables is most relevant to the user's request? And it will probably land on device process events because of my query. And then it will choose device process events, and then it knows like which fields to get from device process events based on this description down here as well. So time generated, etc. So I'll show you like what this means, right? So basically it's going to send the user message, which is I'm worried, telling GPT I want to use model 4.1, and then it's going to use these tools. And then for the choice, it means auto choice. So it's going to just do its best to pick the stuff that's relevant to what we want to do. It's more complicated than this, but I'm making it like kind of short. So I'll like play this. And then it finished, GPT responded, and then it basically told it to use probably the device process events table. Oh, it picked the device name too out of the prompt, right? And then it chose the time range of 96 hours because remember our user message, if we can see it, I said, remember the last 4 days or so was a misspelled 4 and it's all messed up, but it was able to like interpret that into being 96 hours because that's 4 days. And then for the fields to look in, it chose these fields based on our tools file. This is where we describe what our environment looks like. So it can like make the decision of where to look, right? And then it paused. So now I'll resume this. So it took all of those parameters and it constructed what's called a KQL query, like a Kusto query language. And I'm going to show you something really dope right now. So it constructed the query, and then, which is here. So I'll play this. And then this is the query it made here. So I'm going to copy this actually. And I'm going to run the query that it built here. And you can see it returned, oh, let me limit this. Max. And you can see it returned 1951 results. So now our agent is going to do the same query. And somehow it returned like, oh, 2395. Oh, because I need to change this to 96 hours. That's why. Oh damn, how can I do that? Okay, hold on, let me just do this. I can do this. Where time generated is greater than 96 hours ago. That's my raw KQL skill. And then 2395 results, you can see it in the corner. And then this also returns 2395 results. You can see it's querying log analytics and it gets all the logs. Now we have the logs. And then it's building, the next thing it's going to do is build the threat hunt prompt instructions. So basically, this log analysis prompt, this is in utilities log analysis prompt. So I'm going to show you what's inside of there. So this is the log analysis prompt. It's basically like I said, this prompt is going to get sent to GPT 4.1 along with all of the ton of logs. And it's saying, I will provide raw logs underneath this heading where it says raw logs. Please analyze them, blah, blah, blah. Look for anything that you can find. I just made this prompt like really fast. and then please output stuff in this format so we can like do something with it. It's just a prompt, and then after the prompt, this is where all those like 2,395 logs are going to go. So it's just sending them to ChatGPT. Essentially, that's like a really easy way to think about it. So if we play this, it's initiating cognitive threat hunt against targeted logs. So that big prompt, all those logs getting sent to GPT. And there's another system prompt as well that gets included with it, but that's I'll talk about that like later in the course. You can look at it in the source code I'm going to include in this video, so if you want. But yeah, and if you're feeling like overwhelmed by this, it is a lot. It's a lot built on top of a lot. But I can code, so I was able to put it together. But I don't want you to feel overwhelmed by it. You just have to learn it like piece by piece by piece by piece, and then at the end you're going to be able to make complete sense of it. And then you're also going to be able to like augment this and like make it better for yourself. And that's what like the course, I guess, is going to be about. There's more stuff in the Cyber than this thing. There's like whole vulnerability management, traditional threat hunting, security operations, incident response, SIM. It's like a full-on environment with like a ton of stuff in there. And probably the idea is I'm probably gonna like tell people to go through like the traditional threat hunting and SOC stuff, so it actually makes sense, and then you'll get into like the AI portion where you like really learn like how to utilize AI. It just makes more sense if you have like a foundation already. This thing is like taking some time, it looks like, probably because there's like literal ton of logs. But if you imagine this like a normal human trying to do this, for sure is take like 300 to 500 times as long, considering the fact this is probably going to take like a couple of minutes, right? So okay, so the threat hunt is finished, and we can see it took 102 seconds and found 6 potential threats. That many logs, like to find the threats and to like make reports with all the TTPs and like everything, that will take like a day, like few hours, right? But I'll just like press enter and we can look at these. Again, I'm not going to like go into super depth with these, but I'll just show them all on the screen so you can like maybe get a sense. And again, like I don't know like what's inside of these, because like I just like picked a random person from the Cyber range. So I'll let you like look through them, ask questions in the comment section if you want. We have an attack simulator in the Cyber range, so some of this is for sure from that. But yeah, credential dumping, data exfiltration via PowerShell scripts, the specific logs that came from the IOCs. It's funny, Josh Madakor one. This is for sure the attack simulator, because it's literally getting code from my GitHub and launching it. This might be small for you. Threat number 2, unauthorized execution of potential ransomware, confidence high. Threat 3, abnormal PowerShell scripting, downloading and execution of ICAR. ICAR is like a test thing, for testing malware. Potential threat 4, suspicious chain installation of potentially untrusted 7-zip with the IOCs. Threat 5, persistence and reconnaissance via abnormal repeated PowerShell and service enumeration. This is not me. I don't know what this is. This would be something that I would probably like look into. Potential 5, abnormal user process behavior, repeated installation, scripting custom tools. You can look through this if you want. And finish. Yeah, as you can see, really, really exciting. And this is like the most basic one. Again, I made this in probably like 6 to 8 hours. Like yesterday, I just like coded it up. And you can augment so much more onto this, and it will be relatively trivial to like branch and make decisions and like talk to like the virus total API to see if something is malicious. Completely fun, and it's just like really cool. So yeah, if you're worried about like L1 SOC Analyst position going away, this is why. But the good news is a lot more positions are going to be created, and if you know how to code, it's going to help a lot. And people are always like, oh, ChatGPT like knows how to code. Like we don't need to code. Like obviously somebody needs to know how to code, right? Somebody needs to, because it's not like somebody who doesn't know how to code can just like make this in a day, right? There's a big difference between somebody who doesn't know how to code using GPT and somebody who does. But anyway, ask any questions you want in the comments. Join the Cyber Range if you want. Again, there's like a max, theoretical max of about 2,000 users. We can probably have about 3,000 users before I have to scale it out again. And I will, anyway, I'll put links in the description for all of that, so check it out. Also, we have an interesting Instagram. We talk about physique building and health and lifestyle and just being productive. Like me and my team, we work abroad, like exclusively at like Thailand, Japan, random areas. So we have a lot of high effort content in there. So check that out as well. We'll see you in the next video and possibly see you in the Cyber Range as well.